All right, we're taking a look at R as the region in the first quadrant enclosed by the graphs of g of x equals the square root of x, and h of x equals x cubed, x over 3. Find the area of R. So this is just a straight up first quarter area, top minus bottom. So our top function is the square root of x. Our bottom function is x cubed. And it looks like we're going to go from, in the first quadrant, from 0 to 9, because that encloses them. 0 to 9, square root of x. And I'm going to write it as 1/3 x dx. And we do want to find the area, not just set up the integral. So we are going to integrate. So we've got x to the 3/2 over 3/2 minus 1/6 x squared from 0 to 9. Now, the 9's convenient because when we put that in, we're going to get square root of 9 cubed, which is 27, times 2/3. So divided by the 3 again is 9, so that's 18. 9 squared is 81 over 6. That would be an acceptable answer. I think if you simplify that down, I think you can take a 3 out of that, of course. So you've got 18 over 1 minus, I think it's 27/2. 18 minus 13/2 is 4.5, I think is the answer that I most commonly saw. And then a lot of times, you're going to see a problem like this. You're going to find some area, and then you're going to do some things with that area. And the first thing we were asked to do with this one was revolve it around the line y equals 4. And tell me set up the integral to find its volume. So my rough sketch would be something, let's go straight on the outside and then some kind of a curved inside. There we go. So I would write the word washers. Pi big R squared minus pi little r squared. Now, it's not just as straight up as that, like the top minus bottom is in the one before that. We've got to think about what's going on. For my top equation, we start at 4, and then we go to the outside. So what's that function going to be? That's going to be 4 minus x over 3. That will get me this value right here. This is a y value. This is 4. So it's 4 minus that y value. And that y value is x over 3. So that's my big R. Oh, and then we've got our dx out here because our washers went that way. So then once we get that R, we're going to know that inside R. And that's going to be the same 4 minus the inside function. 4 minus root x. And don't forget our pi in front. And then we're still going from 0 to 9. I think that's what we went over in class. But just reviewing that would be very good. And then I'm going to go off script here for the last part. I think because we've got this area, I would like to talk about finding the volume of a cross section, because I think we're pretty good at that. Let's make them equilateral triangles, and let's say first perpendicular to the x-axis. So that's going to be right here. And that actually looks a lot like part A. The height of each one is going to be square root of x minus x over 3. And then our formula for an equilateral triangle is side squared root 3 over 4. And we're going from 0 to 9. That's great.